This is lesson 7-1, solving a system of linear functions by graphing.
Here's some vocabulary that we need to go through for this lesson. A system is two or more functions that apply to any given situation. For our purposes, we will only ever be using two functions at once. For this lesson, we're going to specifically focus on two linear functions. Let's talk about consistency versus inconsistency. A system is consistent if it has at least one solution. It's inconsistent if it has no solutions. Let's talk about independence versus dependence. If a system is consistent, then it has to be described as either independent or dependent. So independence and dependence only happens if we have a consistent system. If the system has no solutions, then we do not worry about independence or dependence. If a consistent system is independent, it has exactly one solution, and this is what happens most of the time. If it's dependent, it has infinitely many solutions, and it means it's the exact same linear function, just written a different way. Here's your procedure for solving systems by graphing. Number one is to make sure both linear functions are in slope-intercept form. That you should remember is y equals mx plus b. Then, graph both lines using the slope-intercept method. If you don't remember how to do it, take a look back at the notes on slope-intercept form. It's lesson 5-3. You have to label both lines on the graph with the original functions. If you don't, you would lose points on the regions. Make sure to state the results in words. If a system is consistent or inconsistent. If it's consistent, state if it's independent or dependent. And if it's independent, circle and state the point of intersection. If it's dependent, state that it is such. Here's an example. Pause the video at this point to give yourself a chance to do the example. So the first thing I want to do is graph the first function. I need to change it into slope-intercept form as I've done below. You'll notice that this entire function will be graphed in red. I then plotted points, connected the dots, and labeled my function. I'm going to do the same for the second one in blue. Connect the dot, plot the points, connect the dots, and label the function. This group of functions, this system of functions, has a point of intersection. So I'm going to circle it and state the point of intersection, which is 4, -3. Here's a word problem example. Read the question carefully. Pause the video at this point to give yourself a chance to do the work. So we have alligator 1 and alligator 2 as our two equations that we need to create. So W is going to be the alligator weight, and T is going to be the time. For alligator 1, he initially had a weight of 4 pounds, and he added 1.5 pounds each month. For alligator 2, it was 6 pounds as an initial weight, with a growth of 1 pound per month. So now we need to graph to see after how many months did the alligators weigh the same amount. It is okay for me to use just the upper right-hand corner of the graph because I am only dealing with positive values with time and weight. So now I'm going to graph W equals 4 plus 1.5t. I am going to change that so that it is 3/2 t, so I have my fraction a slope in a fraction form, and I have it in slope-intercept form. I plot my points, and I do my line. And I label it with the original function. Now the other one. I'll do that one in green. Plot my points, draw my line, and I have a point of intersection. So at what month are they the same weight? Right at 410. So they're both going to be 10 pounds after 4 months. If you're having issues with this lesson, please consult your teacher in class.